Variation of negative binomial. So we are going to start with mean. Our e of x is given by summation from x is equal to 0 to infinity of x times the PDF of a negative binomial, which is x plus r minus 1 p of x to 1 minus p of r. So from here, x is equal to 0 to infinity. That means x 1 0 1 2 2 other numbers to infinity. So when x is 0, we are going to have 0 times this entire thing, x plus r minus 1 p of x into 1 minus p of r, plus when our x is 1, shall have summation x is equal to 1 to infinity of x times x plus r minus 1. We write this p of x, but any number times 0 is going to be 0, so the whole of this is 0. We shall have our e of x will be summation of x is equal to 1 to infinity of x times x plus r minus 1 into e of x. So we are going to expand this, factorizing. Let's go for this. We shall have x is equal to 1 to infinity of x times, this will be x plus r minus 1 factorial. Out of this will be r minus 1. Okay, this is our success, probability of success. This is probability of failure. So it will be this factorial into this, the failure, minus this, right? X plus r minus 1 minus r minus 1 factorial. We maintain px into 1 minus p of r. So we shall have summation x is equal to 1 to infinity x times x plus r minus 1 factorial out of r minus 1 factorial. This, when you simplify this, you get x, remain with x factorial to p of x 1 minus p of r. But now this x factorial can be written as x into x minus 1 factorial. So we're going to substitute this into this. Shall have summation of into x plus r minus 1 factorial out of, when you substitute this, you shall have x into x minus 1 factorial r minus 1 factorial p of x 1 minus p of r. So this and this is going to cancel, shall remain with that. But okay, let me first write this. So this 1 out of r minus 1 factorial can be written as r out of r minus 1 r factorial, which is the same as r out of r factorial, right? And then even this, when we simplify that, shall have p minus 1 p of x. This is the same as this because this doesn't change meaning, right? When you simplify this, you're going to get this. So we shall have p of 1 p into x minus 1, then p of 1 minus p of r will be 1 minus p 1 minus p negative 1 minus p of r, which is the same as saying 1 minus p of negative 1 to 1 minus p of, I'm going to add these powers, r plus 1. So we're going to simplify, substitute this into this. Then we'll have summation of x is equal to 1 infinity x plus r minus 1 factorial to we're supposed to substitute this by this, so we shall have r out of r factorial times this px is the same as this, shall have p to power 1 to px minus 1 times 1 minus p minus p. But look at this, is a constant, this is a constant, this is a constant, so we pull out the constants, shall have r p into 1 minus p summation of, this is what we remain with when we factorize out the constants, px minus 1 minus p r plus 1. But now we can let this be a single letter as well as this, so we can assume w, let w be equal to x minus 1, then let s be equal to r plus 1. From here, your x is the same as w plus 1. Here, your r is the same as s minus 1. Then we're going to substitute this into this equation. Shall have rp into 1 minus p to be x is w plus 1 is so here when you simplify you get this cancel. When you simplify you get w plus s minus 1 factorial out of, so s minus 1, then this x is w plus 1 minus 1, this one and this will cancel, shall remain with s minus 1 factorial w factorial. So okay, to save time, this is the same as the whole of this is equal to 1. That's from negative binomial. Save time, this, the whole of this is equal to 1. This is from negative binomial distribution. This is equal to 1. Okay, it's the same as saying, okay, this entire function is the same as saying summation is x and to probability of w s, which is 1. So we're just going to multiply this by 1. Shall have rp into 1 minus p negative 1 times 1. So I'm saying r out of, so if you bring this to the denominator, shall have that. So that's our expectation or mean of a negative binomial, right? Now we're finished deriving the expectation of a negative binomial, which is rp out of 1 minus p, right? So now we're going to look for the SD. Standard deviation is the square root of the variance. SD is square root of variance. So we are going to get the variance of a negative binomial. So variance of a negative binomial is, okay, this is the standard variance formula, which is ax squared minus e of x squared, but we already have this, which is this, e of x squared minus rp out of 1 minus p squared. Now we have to look for the e of x squared, which will be equal to x is equal to 0 to infinity of x squared times probability of x plus r minus 1. This is success and failure, failure and success, whatever. So when x is 0, shall have 0 squared into p into x plus r minus 1 plus when x is 1, x squared into then when x is 1, shall have summation of x is equal to 1 to infinity of x squared to p of x plus r minus 1. So this is entirely 0. We're going to be working with this. Shall have summation x equal to 1 infinity. This, okay, this expression can also be written as x plus r minus 1 r minus 1 to p of x 1 minus p of r. So now we are going to simplify this, or rather factorize it. Shall have x squared times x plus r minus 1 factorial into r minus 1 factorial. When you subtract this from this, you'll get x factorial 2p of x 1 minus p of r. Now we can expand this. Have to be x into x minus 1 factorial r minus 1 factorial p of x 1 minus p of r. This and this 1x shall remain with this. Summation of x is equal to 1 x times x plus r minus 1 factorial 12 factorial r minus 1 factorial p of x 1 minus p of r. But now this is almost the same as what we did in expectation, so I'm just going to cut some steps. Okay, so here, this earlier we saw that 1 out of r minus 1 factorial is the same as saying r over r factorial. Even this was simplified, so I'm just going to substitute from that. So shall say summation will be x times x plus r minus 1 factorial out of r factorial into x minus 1 factorial of p 1p into x minus 1 1 minus p r plus 1. So from here, putting out the constants will be r p to 1 minus p negative 1 summation of So now from here, let w be x minus 1, then s be r plus 1. So we're going to substitute in. Shall have this constant into our x will be w minus plus 1. This is into okay. So when you simplify that, shall have plus 1. This multiplies everything, right? We have plus s minus 1 factorial 12 s minus 1 factorial w factorial. So from here we're going to multiply this bracket, okay, this by everything. Okay, yeah. So when you multiply this by everything, you shall have summation of x w equal to 0 to infinity w times y plus s minus 1 plus this 1 times all this. But for a negative binomial, we know that, the summation equal to 0 to infinity. For negative binomial, we know that this entire function can be written as this. Which is equal to 1, right? And this is expectation of w, which can be written as sp out of 1 minus p. So to save time, we shall just substitute, shall have rp to 1 minus p negative 1. This will be sp 1 minus p plus 1, this one times that, shall have rp so here we replace this s, because originally from this our s is r plus 1, so we shall just replace rp r plus 1 to p plus 1. Now here, okay, to save time, this we're going to find the LCM. We simplify this and we shall have something like this, 1 minus p to be p plus 1, the same as writing it as rp plus 1 minus p plus 1. So now this is just our e of x squared. From variance, we're supposed to subtract this rp plus 1 minus minus our expectation, which was rp out of 1 minus p squared. So from here, just going to have rp out of 1 minus p squared, multiply this by everything in, plus rp p squared minus rp out of 1 minus p squared. So when you open bracket, shall have rp out of 1 minus p everything squared plus rp out of 1 minus p squared minus rp out of 1 minus p squared. So this and this will go, shall have our variance as rp out of 1 minus p squared. But remember, the question wants standard deviation, so sd will be root of variance, which is rp out of 1 minus p squared, same as saying root of rp out of 1 minus p. So this is our standard deviation.